so we're going to pick up right where we left off. I'm just going to work through the rest of this. It's going to be kind of long, but you'll be fine. You'll survive. Okay, question 18, we're finding the zeros. So that's when you're actually starting to find the x-intercepts. So up here, we were just factoring, easy peasy. Now is when we take it to the next step. So that's when we take these two quantities and we set them equal to 0. So I would have x plus 3 equals 0 and 2x minus 1 equals 0. So then when I subtract the 3 from both sides, I get x equals negative 3. Two-stepper, so I have 2x equals 1, divide by 2, x equals 1/2. So my x values are negative 3 and positive 1/2. Remember, these are the x-intercepts. That's where the parabola would cross the x-axis. Okay, this one is not factored for us, so first we have to factor it and then do this same process. So what times what equals negative 63? What plus what equals negative 2? So you get negative 9 and 7. So we have x minus 9. And then we would set that equal to 0, and x plus 7, and set that equal to 0. So really, the x minus 9 would have been one of these quantities, and the x plus 7 would have been the second quantity. So instead of writing them as quantities, I just went ahead and set them equal to 0. So I have x equals 9 and x equals negative 7. So those are my answers for that problem. Down here for number 20, it's a little bit more work because we have an actual value here for a. It's not just 1, so we have to do the AC method. So when I multiply those, I get what times what equals 20. What plus what equals 9. So we get the positive 5 and positive 4. So then I have to, if you remember, once you have those quantities, the next step is to put your original a into the quantity. So I'm going to have 10x plus 5 times 10x plus 4. That's where that 10 goes in there. And then I have to ask myself, do either of these have a greatest common factor? And it turns out both of them do. So this can be 5 times the quantity 2x plus 1, and this can be 2 times the quantity 5x plus 2. And then when I divide by my original a, that's where that 5 times 2 cancels out with the 10 in the denominator. So now I have these two quantities. 2x plus 1 equals 0, 5x plus 2, set that equal to 0. So once I do all of that, I'm going to get x equals negative 1/2, x equals negative 2/5, because I would subtract the 2, divide by 5, subtract the 1, divide by 2. So those are my two x values. I'm going to go ahead and put a little border around those so they stand out better on your paper. This one's a little bit easier, kind of, but if you remember, there's no just term with x. Sorry, let me just get the paper over. So that means that when we actually do the what times what plus what, we try to make it equal to 0. So what times what equals negative 225. What plus what would equal 0, right? Because there's nothing for that b value, right? So that's why we know that they had to add up to equal 0. So this is where we get negative 15 and 15, right? So again, I'll put that a in the quantities. So I have 25x minus 15 times 25x plus 15. They both have greatest common factors of 5. So this would be 5 times the quantity 5x minus 3, 5 times the quantity 5x plus 3. Again, if I divide that by my original a, that 5 times 5 is 25, cancels out with that 25. So now I have these two quantities down here. So I have 5x minus 3 equals 0, 5x plus 3 equals 0. Once I would add and then divide, I would get x equals 3/5 and x equals negative 3/5. Those would be my two x-intercepts of my parabola. That's where the actual curve of the parabola would cross the x-axis. Okay, moving right along to our next topic, which is finding the roots using the square root method. Okay, so this is where we would take the square root of x plus 3 squared and take the square root of 64. So we end up with x plus 3 equals plus or minus 8, because remember, you can multiply 8 times 8 and get 64. You can also multiply negative 8 times negative 8 and get 64. So this is where I'll set up two separate equations. X plus 3 equals 8. X plus 3 equals negative 8. So I'm going to get x equals 5 and x equals negative 11. So for this one, 5 and negative 11 would be my answers. The next one is a little bit different, but not really. It's just kind of looks different. So the first thing I would do here is I would add the 5 to both sides. So now I have x plus 6 squared equals 5. So I'm kind of at this stage now. I'm at this stage was where, so all I had to do was add the 5, and now these two stages are the same. I'm going to do the same thing. I'm going to take the square root. So then I have x plus 6, right, because the square root of 2 of them would just be 1, equals plus or minus square root of 5, because I can't do anything with that. And then you can just leave it like that. I would accept that. Or you could do x equals negative 6 plus or minus square root of 5, because if I subtracted the 6 over here, it'd be right there. And then also there are, let me pull out my Desmos calculator, because I know some of you put this into decimal value. So if I have negative 6 plus square root of 5, I get negative 3.76. And if I do negative 6 minus square root of 5, I get negative 8.24. And those are approximate values, right? Because they don't end. Because it's a square root, it's an irrational number, so those are going to be approximates. For number 24, similar situation here. This one, though, I can't use AC method, I can't use square root method, I can't use anything except your favorite, the quadratic formula. Opposite of b plus or minus the square root, b squared minus 4ac all over 2a, right? So I'm going to have negative 6 plus or minus the square root of 6 squared minus 4 times 2 times 3, all divided by 2 times 2. So I have negative 6 plus or minus the square root of 36 minus 24 divided by 4. So then I have negative 6 plus or minus the square root of 12 divided by 4, right? So if you left it like that, that's fine. If you wanted to actually put it into the calculator to get the decimal values, you can do that as well. So I'm going to start out as a fraction. Remember, if you want to put this into your calculator, you need to start out with a fraction so that you can have everything in the numerator. So I would have negative 6 plus the square root of 12 divided by 4, and I get negative 0.63. And if I go change that to negative 6 minus 12, I get about negative 2.37. So if you wanted to put it into your calculator, these would be the two decimal values you could get. Number 25 is also similar. Okay, so I'm going to subtract minus 7x minus 8 equals 0. And I do that because I don't like having a negative as for an a value. So I just bring everything over here. And I'm going to do my quadratic formula again. So I'm going to have 7 plus or minus the square root of 7 squared minus 4 times 3 times negative 8, all divided by 2 times 3. So I'm going to have 7 plus or minus the square root of 49 plus 96, all divided by 6. So then I get 7 plus or minus the square root of 145 divided by 6. And then if I wanted to find the decimal values of that, I would have 7 plus square root of 145 divided by 6, and I get about 3.17. And then if I change that so that it says minus, I get about 8.84. And those are the two numbers you can get for that answer. Again, you could stop here if you wanted, but I know some of you like to take it to the decimal value. Okay, determine the x-intercepts of each equation's graph. So again, this is exactly what we've been doing. This is still finding the zeros. Okay, so nothing different here. This one looks a little weird, so I'm going to take, this has a greatest common factor of x. So x times the quantity x minus 9 equals 0. So I have x equals 0 because x set it equal to 0. And then x minus 9 equals 0, which tells me x will equal 9 once I add that over there. So my solutions are 0 and 9. Well, I guess if we were being super formal, we would say my x-intercepts are 0, 0, and 9, 0. Similarly over here, I'm going to subtract this 30, so I have everything x squared plus 7x minus 30 equals 0. So what times what equals negative 30, what plus what equals 7. So I'm going to have 10 and negative 3. Then I'm going to have x plus 10 equals 0, x minus 3 equals 0. So x will equal negative 10 and x will equal positive 3, right? Because if I subtract the 10 over here and I add the 3 over here, so my solution is going to be negative 10, 0 for one of the x-intercepts and 3, 0 for the other x-intercept. All right, next page, sketch this graph. Okay, it says, be sure to give the coordinates of the vertex and the equation of the axis of symmetry. All right, so this is where we come into how do we find the vertex, and then we find an opposite, or then we find use the y-intercept, then we find the opposite of the y-intercept, all the things. Okay, so remember to find the x value of vertex. We do opposite of b over 2a. So we're going to have negative 2 over 2 times 1. So that's going to be negative 1. And then the y value of vertex, we put the x value into this equation. So y will equal negative 1 squared plus 2 times negative 1 minus 3. So y will equal 1 minus 2 is negative 1, minus 3 is negative 4. So my vertex equals negative 1, negative 3. My axis of symmetry equation is x equals negative 1. Remember, that's always the value of the x value of my vertex. So let's go ahead and plot those. So negative 1, negative 3. And then this is my axis of symmetry. Okay. My y-intercept is going to be 0, negative 3. So 0, 1, 2. Sorry, this should be negative 4. What am I doing here? Negative 1, negative 4. There we go. My y-intercept is 0, negative 3. So then the reflection of that is going to be negative 2, negative 3. So I have 2 points. Excuse me, I have 3 points. I need 2 more. So remember, this is where I just choose an x value. So I'm going to say if x equals 1, then I would have y equals 1 squared plus 2 times 1 plus 3. So my y value would be 5, right? 1 plus 2 is 3. Oops, my y value is going to be 6. So I would go over here and up 6. And then I would go, so 1, 6. So this would be back here, 1, 2, 3, 4, 5, 6. And now I have my parabola. Does that make sense? I don't know. Oh my gosh, you guys, I'm sorry I keep messing this up. This is supposed to be a -3. Like, why doesn't this look right? I know it doesn't look right. You probably all figured it out before I did, and you were like, Mrs. Marsh, wake up. So that's going to be 3 minus 3, which is 0. So my x, it happens to be the x-intercept would be 1, 0. So then this is also going to be at -3, 0. And now I have my parabola. That looks much better. Okay. Good times. All right. Express the following in simplest radical form. This is where we do our factor trees, right? So I used 3 times 30. We circle our prime numbers so we know that those are done. 3 times 10, 2 times 5. So then I write this as square root 2 times 3 times 3 times 5. I look for the pairs. Where I see a pair, that comes out. So I have a pair of 3s. It comes out as a single number. And then I'm left with 2 times 5. So then 3 square root 10 is how you get the simplest form of square root of 90. For this one, I'm going to do the same thing. I'm going to start out doing a factor tree. I used 12 and 7. So I get these factors. I do a square root, and I have 2 times 2 times 3 times 7. These 2's come out, so I'm going to have 2. And then I have to go back to this. Remember, I'm looking for pairs. So how many pairs of 6's do I have? Well, I have 3 pairs of 6's. 3 pairs of x's. And then how many pairs of y's? I have 4 pairs of y's. But then I have a single y hanging out by itself. So I'm going to have this 21 from the 7 times 3, and then I have that y that didn't have a buddy. So that would be the simplest radical form of that value. All right, number 31, here we go. We have a function here, baseball, hit from the batter's box, okay? X is the time in seconds the ball is in the air, y is the height. So find the maximum height, so that means we need the vertex. And then the height will be, of course, the y value. So if I'm going to find the vertex, opposite of b over 2a equals -96 over 2 times -16. So I have -96 over -32, which equals 3. So that's the x value of my vertex. So then I put that 3 back into the equation. So I get y will equal -16 times 3 squared plus 96 times 3. So that will give me -144 plus 288. So that equals 144. So my vertex is 3, 144. X value is 3, y value is 144. So the height of the ball is 144 feet, because that is the y value of my vertex. How many seconds after does the ball hit the ground? Well, if it takes 3 seconds to go up, it's going to take 3 seconds to go back down. 3 up plus 3 down. All right, so that's going to be 6 seconds. We know this because our y-intercept is 0, so we don't have to factor that in. So that just means that 3 up and 3 down. All right, we're getting closer. Oh, everybody's favorite. We've got some frequency tables. Okay, remember the first thing I told you guys to do was fill these in. Right, so this is going to be 44. This will be 36. So that equals 80. This is 38 plus 42. That will also equal 80. Remember, you want this column and this row to add up to the same. What is the joint relative frequency of a spectator who did not enjoy the experience but did purchase food? So did not enjoy the experience but did purchase food. That is 16 people that fit that scenario. And we're going to take that 16 out of the total 80 because it's joint relative. So that means it's this tiny little joint out of the entire total. What's the marginal relative frequency of spectators who did not purchase food? Okay, so we're going to take the total of spectators that did not purchase food out of the total number of spectators. Oh my gosh, you guys, the air just popped on in here and it was already kind of chilly. Bring your sweatshirts. Okay, now we've got conditional relative frequency. Among the spectators that did not enjoy the food, remember we were supposed to change this to purchase. Spectators who did not purchase food, so that is, there's 36 that did not purchase food. That's going to be my denominator. What is the conditional relative frequency? They did not enjoy the experience. So, did not enjoy. Okay, so the did not purchase is 36. Total people did not purchase. And how many people did not enjoy the experience? So there's 16 out of the 36. So did not enjoy the experience, did not purchase food. 16 out of those 36. Okay, among the spectators that enjoyed the experience, what is the conditional rather that did not purchase the food? So this was where we had to change that to purchase. And I'm sorry that it's like you can barely see my writing because it's glaring. I don't know. Maybe that'll help. Okay. So did enjoy the experience. And then did not purchase food. So we really just flip-flopped them. So how many did enjoy the experience? Well, there were 42 who enjoyed the experience. And how many of those did not purchase food? So that would be 14 out of the 42. Right? So enjoyed experience, that's the entire column up there, that's 42. Enjoyed the experience. And of those that enjoyed the experience, 14 did not purchase food. Okay, let's talk about data. More data. A high school cafeteria is considering a new kind of French fries. On Tuesday, the cafeteria served 125 students the regular fries and 125 students the new French fries. Every other student in line received a different type of fries. The population is the 1,500 students at the school. And the sample is 250 students with fries, right? So the whole 1,500, only 250 were actually given the two, old and new, and actually asked about it. Okay, is it an example of a random sample? Yes, because it was every other student. Right? Is this scenario a survey, experiment, or observational? This is going to be an experiment because one group had the old fries and one group had the new fries, right? It would be a survey if they asked them about it. Maybe it would be both. Because if they give them the new fries, they also have to ask them about it, right? So I think it's an experiment and a survey. Don't worry, there won't be one on the test where it's like, could be both. But I think you could argue either way. All right, provide 2 reasons why this graph is misleading. Let's see, it doesn't start at 0. on the y-axis. That's a red flag, okay? And we don't, frequency of what, right? How far are they biking? What's the frequency? And then also if you look down here, the increments, we have 0 to 29, 30 to 59, and then 60 all the way up to 119. So unequal increments. There's a whole lot wrong with this. We have no idea what's happening here. Frequency of what? This could be anything. Okay. Last page, guys. Last page. Perform a linear regression on this data. Write the equation of the line and the best fit. Okay, so let me get out my linear regression app. Bust out my iPad for this. Okay. Remember, for linear regression, we enter in the x's and y's. Sorry, my iPad's loading. Okay. Here we go. Let me delete all my old data from the assessment. And if you don't remember how to find this, okay. So we have 2, 24, 3, 23.5, 4, 34, 5, 37.5, 6, 44.5, 7, 52, 8, 48.5, and 9, 39. So once you have all that in to your app, then you remember you look down here at this section, okay, and you have your slope, you have your y-intercept, and then you have your correlation coefficient, which is this r value, right? Not r squared, but the r alone. So when I get to here, my equation is going to be y equals 3.46x plus 18, right? So we're talking about ice cream sales in the thousands, so that would actually be like 3,460 plus 18, right? That's our y-intercept. Provide and interpret the correlation coefficient. So correlation coefficient, r equals 0.8081. I mean, this would be a moderate positive. It's not strong because it's not super close to the 1 or the -1. And I think that's because this dipped down here. Like we had some low numbers here that kind of threw the data off a little bit. We had this 39 and then it dropped down to 48.5. So we would say moderate positive correlation, right? You really only can say strong if it's in the 9s, like -0.9 something, +0.9 something. Use your equation to determine the expected sales for the month of January. So 1 month. So this is February to September. So what would it have been in January? So I'm going to put y equals 3.46 times 1 plus 18. So when I clear this out, I have 3.46 plus 18, right? So that would be about 21.46 thousand. You could say 21,460. Okay, use your equation to determine the expected sales for the month of December. So month 12, so same thing, y equals 3.46 times 12 plus 18. So again, if it's if I'm using the same equation, I get about 59.52, so that is $59,520. So they're going to make a rebound a little bit. All right, a new car is worth $45,000. It decreases in value by 15% each year after its purchase. Use this information to complete items 44, and 45. Okay, so remember we have y will equal our principal, which is the A, 45,000, times what's left. So if they decrease in value by 15, that means that the only value it has is 85% year after year. And then we would have however many years old the car is. So that would be your equation. And now we're going to use that equation and put in the number 10. So y equals 45,000 times 0.85 raised to the 10th power. So if you remember correctly, you can put this whole thing into your Desmos. 45,000 times 0.85 raised to the 10th power. So after 10 years, the car is only worth about not even $9,000. So our answer would be $8,859.35 if I round up. So that would be the value of the car. All right, that was a lot. You can go back, pause, watch at your own pace, obviously. Remember, part 1 was on Friday for you to watch as well. Okay, thank you.